Okay, so now we'll look at integrals of this form where we're integrating secant to the nth power, the secant of x to the nth power dx, where n is odd and positive. So we're going to look at integrals of this form where we have secant raised to an odd positive power. And in order to do this, what we're going to do is we're going to do integration by parts. So let's take a look at an example. Let's take a look at the integral of the secant cubed of x dx. All right, now what I want to do is I want to rewrite this as the integral of the secant squared of x times the secant of x dx. And the reason I want to do that is I want to make my choice of u and dv. The choice that I want to make for u is the thing that gets simpler when I take the derivative. With trig functions, there's not really any getting simpler. So really, I want to make the correct choice for dv. dv will get simpler if I integrate it, if I choose dv to be the secant squared, because if you integrate the secant squared, you get the tangent. So if you make the choice of dv, the secant squared of x, then the choice of u is obvious. U is just equal to, and actually dv would have to be the secant squared of x dx, and then the choice of u would be the secant of x. And there we can take the derivative of that to get du dx, the derivative of u with respect to x. Well, the derivative of the secant of x is the secant x tangent x, and the derivative and when you multiply both sides by dx, you get that du is equal to the secant x tangent x dx. dv, if you integrate both sides, well, if you integrate dv, you get v, but that means you have to integrate the secant squared of x dx. And if you integrate this, you get v, and if you integrate the secant squared of x, you get the tangent of x dx. So there we have everything we need. So this integral, the integral of the secant cubed of x dx, that integral is going to equal, and then we're going to do uv. That's what integration by parts says. The integration by parts says the integration of u dv is equal to uv minus the integral of v du. This is what we're using, the integration by parts formula. So that means we have this integral is equal to u is the secant of x, times v is the tangent of x, minus the integral of v is the tangent of x again, tangent of x dx, du, and du is the secant x tangent x dx, because this doesn't need to have a dx on it. So when you integrate dv, you get v, but when you integrate this, the dx goes away, you just get a tangent. So this is the integral that we have now. This is the integral that we have now. And I see here that I have this integration to do still. So I have the integral of the secant cubed x dx is equal to the secant x tangent x minus the integral, and tangent times tangent is tangent squared of x times the secant of x dx. Now what I'm going to do here is I'm going to convert this tangent squared factor into a secant squared factor to continue the integration. So I'll get the integral of the secant cubed of x dx is equal to the secant x tangent x, and then over here, well, let's see, I have here this I'm going to change into, well, the tangent is equal to the secant squared minus 1. So secant squared of x minus 1 times the secant x dx. So I will have this. I'll have the integral of the secant cubed of x dx is equal to this now. Well, I have the secant tangent, secant x tangent x. And then what I'm going to do is I'm going to distribute this secant x dx and the negative to both of these terms, this one and that one. So let's see, I have negative integral, and when I multiply secant x dx times secant squared of x, I get the secant cubed of x dx. And when I distribute, negative times negative becomes positive, and 1 times secant x dx is just secant x dx. All right, this is what I want you to notice from here. There's a trick that I'm going to employ. This is the original integral. This is the original integral. This is what I'm actually trying to integrate, right? This thing right here. But notice that it appears in the answer over there, right here. You see that integral still appears in the answer? So what I'm going to do is I'm going to move that integral over to this side, collect like terms, and then all I have to do is the integral of the secant, which is relatively easy. So we come back up here. All right, so I'm on this step here. I'm going to rewrite that step. I have the integral of the secant cubed of x dx is equal to the secant x tangent x minus the integral of the secant cubed of x dx plus the integral of the secant of x dx. All right, so I have that. What I'm going to do, since, like I said, this term appears on both sides with equal sign, I'm going to put them both on one side with equal sign and collect like terms. So I'm going to add the integral of secant cubed of x dx to both sides. Add the integral of secant cubed of x dx to both sides with equal sign. That way I'll get this. This is 2 of them. 2 integrals of secant cubed of x dx equals secant x tangent x plus the integral of the secant of x dx. These cancel out. So I get this thing, and then all I really have to integrate is this secant of x dx. The integral of the secant of x dx is the natural log of the secant plus the tangent plus c. So I have 2 times the integral of the secant cubed of x dx is equal to the secant of x times the tangent of x plus, and then when I integrate that, I get the natural log of the absolute value of the secant of x plus the tangent of x plus c. So that is twice the integral I'm looking for. That is twice the integral I'm looking for. So if I want to find what this integral equals, I just divide both sides by 2. And I get this. I get, dividing all this by 2, I get the integral of the secant cubed of x dx, when these cancel out, is equal to, well, I'm going to have 1/2 secant x tangent x plus 1/2 the natural log of the absolute value of the secant x plus the tangent of x. And then if I call this constant 1, c1, then this c1 over 2 is just another constant. Half of that constant just gives you another constant that I'm going to call c. So here's the integral. This is the answer right here. All right, so that is how we're going to handle powers of secant that are odd and positive.